Hello everyone. So for number 14, we're taking a look at a table of values. It says average pupil diameter versus age, and they want us to find the average rate of change. That should be a word or phrase that kind of stands out. Average rate of change is something that we deal with, and something that we calculate on a pretty familiar basis. An average rate of change corresponds to, or is very similar to, the phrase slope. For nonlinear functions where they don't have a slope, we find the average rate of change. It's the same as saying slope. You're kind of approximating a line out of some nonlinear function. Long story short, you can just think of this in terms of delta y, or the change in the y values over the change in your x values. And that's what average rate of change is. Okay, so in our case, we're going to start by finding the average rate of change. It wants the slope in terms of millimeters per year. In other words, the year component should be our denominator. And in this case, we're going from, it says from 20 to 80. So I'm looking at this row all the way down to this row. You want to be careful because sometimes it's not always just the top and bottom. Sometimes it has something in between. In our case, it is. So the change there, I'm not just going to write 80. The change is from 80 to 20, or excuse me, 20 to 80. So that would be a change of 60. That's a change in our x values. And again, we're treating age like the x variable here, and pupil diameter, that's what they really want the rate of change of, is our y value. So now we want to correspond. We started with 80 when we found the change in our x values. So what pupil size corresponded to 80? 2.3. Notice how these correspond. If I look at what I set up, 2.3 should go with 80, and then with 20 I have 4.7. Okay, so up top I'm going to have 2.3 minus 4.7. You could just check the calculation on your calculator. 2.3 minus 4.7. You're going to get negative 2.4. Which, look at the choices, again very tricky. 2.4, negative 2.4, and positive are both choices. But we haven't done the calculation yet. We don't have it in terms of per year. Right now it's in terms of 60 years. If we want to make this per year, we actually have to do the division here. So I'm going to take that answer that I just got and divide it by 60, which was our denominator. And I get negative 0.04. Okay, so if I actually divide this out, I get negative 0.04 millimeters per year. In other words, as someone gets older, I'm not sure if this is actually true, but the size of their average pupil diameter is getting smaller by 0.04 millimeters each year that they get older. And now if we look for the choice that corresponds to that, we see correctly choice 4. This is a tricky one because all of the choices kind of have some value or some significance. There's no kind of silly answer that's totally out of the question. Choice 1 and 3 make sense if you kind of just subtracted those pupil diameters for those ages. If you messed up the order, you got negative. If you did them this way, you got positive. 0.04, you could have done everything correctly, but perhaps you forgot about a negative sign somewhere. So all the choices are very close here. The only one that is correct, obviously, is choice 4. And again, average rate of change, always connect that concept. This does happen to be a linear function, so they could have said slope, because it is decreasing by 0.4, it looks like, every year. But whenever you see average rate of change, connect that to slope right away. Okay, and that should help. Thinking about rise and run, y2 minus y1 over x2 minus x1. Average rate of change, think slope. Okay, thank you for watching, and hopefully this helped.